All right, so again, we're still in 1.3. And we're now going to talk about mixture and investment problems. So we're still in 1.3. We're going to talk about mixture and investment. We'll do the investment first. And let's talk a moment about savings accounts, because I always like to find things that we understand so we can see how this relates to different type of problems. If we have a savings account and we get our statement from the bank, what does that statement have on it? Well, it has usually three things. How much money I've got in that savings account. So let's say I got $10,000 in a savings account. What percentage rate it pays out? Maybe it pays 1%. And then the interest earned. So that might be maybe $100 or $10, something like that. But you've got those three amounts. How much money you have, percentage rate that it pays out, and then how much money you made in interest. So those three items. Amount, total amount, interest rate, interest earned. And so that's what we're going to be using when we work out these investment problems. And what we're going to do is we don't want to just invest in one particular part. So we're going to break this investment up into a couple ways. So we don't put all of our eggs in one basket. We might buy some CDs, mutual funds, something like that. But we're going to split our total amount up in a couple of different ways. And we're going to look now at question 55. And this is on page 90. And we're going to begin with question 55. So for question 55, we're going to do this one first because I think this one is one that we'll start with. I think it's easier than some of the others. So we'll do 55, and then we'll come back and do maybe 53 and 56. But we'll start with 55. So Dan has invested $12,000 in bonds paying 6%. How much additional money should be invested in a CD, certificate of deposit, paying 3%, so that the total amount of return on the two investments will be 4%. So let's see what we've got and how we're going to break this up. So I like to use dollar symbols to represent the two different investments. And each investment has an amount of money in that account, and it also has a percentage rate that it pays out. And then over here we have our total amount. Now a lot of times where students make a mistake is they get the total amount of money confused with the interest earned. If we go back to that savings account, the total amount is the $10,000, and the interest earned is only the $100. So you have to make sure you know where things go. We've got bonds and we've got CDs. Now for the bonds, we know we bought $12,000 worth of bonds. And these bonds, they pay out 6%. So $12,000, 6%. What about the CD? Well, we're going to have to invest some extra money. So do we know how much money we have to invest in the CD? No. So that's going to be our unknown. Now, what percentage rate does the CD pay out? Well, it says the CD pays out 3%. So that's over here. And the total amount is going to be adding across, because the total amount these add across. So my total amount is going to be the $12,000 from the bonds plus the unknown amount for the CD. And we want to end up with an average rate of return of 4%. So let's talk about what we've got. So I go into my investment broker and I say, okay, I'm going to put $12,000 in bonds. And I don't want to put all the money in bonds because bonds can be a little risky. Maybe I'll lose a little bit of money. So I don't want to put all my money in the bonds. So I take $12,000 and I put it in some bonds. CDs are guaranteed. So I'm not going to lose any money on a CD. So I want to put some extra money in the CD. We don't know how much, but I want to put that in. That CD is going to pay out 3%. On my statement at the end of the year, I want to make sure I make at least 4%. So my total is going to be the 4% over here. Now, how we do this and how we compare them is we move on now to the interest. And the interest is the amount of money times the percentage rate as a decimal. And so we're going to start off with the bonds here. Okay, so we're now going to build our equation. So we've got our table built. We're going to now make our equation. So the bonds, let's talk about the bonds. We've got $12,000 in the bonds. So that's our amount. And the percentage rate that the bonds pay out is 6%. So that's 0.06. So we're taking what's up here and just moving it down here. So we're taking our percentages and we're turning them into a decimal. And this is our interest. Now, what about our CD? Okay, well, our CD, what interest rate does it pay out? 3%. How much is in there? X, unknown amount. Okay, so now we have the rate of return. I'll put that first as 0.03. And how much is in there? Unknown amount X. So we've got the bonds taken care of. And now we've got the CD. Now what about the total? The total interest. Well, that would be this part over here, and that's 4%, so that's 0.04. And that's going to be 12,000 plus X for my amount. And it's going to make more sense once we do several of these. This is just the very first one. So we kind of drew our diagram so we would see what we've got. We put the pieces together. Now we have our equation. And we're going to be able to solve this, and then that value of X is going to be how much money we have in the CD. So we're going to go ahead and multiply across here. So we've got 12,000 times your 6%. So that's 720 plus 0.03x. On the other side, we're going to use our distributive property to distribute that 4% through. And that's going to then give you that 480 plus 0.04x. We distributed. We need to solve it. Okay, we should be a lot better at solving now, hopefully. So I'm going to move things around. So I'm going to move that 720 over with subtraction. And then I'm also going to move over that 0.04x. So it goes to the left-hand side. You could do it in two separate steps, but I think we've done enough of these now that if you wanted to, you could do it in one, like what we're doing here. So now when we move that 720 over, it cancels out. And watch your signs here, 0.03x minus 0.04x. So that's a minus 0.01x there. And we've got 480 minus 720. That makes it a minus 240. And the 0.04x can cancel there. We're going to now divide by the 0.01 on both sides. And we know a negative divided by a negative is now going to make that a positive. So that then comes out to be 24,000. So what do we know? We know we need to invest $24,000 at that 3%. And that would give us the rate of return that we want. And that's our exit. That's the amount of CDs that we need to buy. So we would need to buy 24,000 in CDs. And I wanted to do this one first because they're all a little bit different, but I think that one's a little bit easier to understand than, let's say, 53, which is what we're going to look at next. They're all done pretty much the same way. But let's go back and look at 53, because 53 is actually a little bit harder, I think, on the setup. And it's a little bit different. So for 53, Michelle invested some money at 4.5%. And 1,000 less than twice this amount at 3%. Her total income from interest was $10.20. How much was invested at each rate? So what we're going to look at here again is our two funds. And then we've got a total amount. So to start off with, Michelle invested some money at 4.5%. So we have no idea how much money is in there. So we're going to use the variable x. And then our percentage rate is 4.5%. Is everyone okay with the setup on that? Okay, so we got our first account. We have no idea how much is in there, but we know it pays 4.5%. And then it is a little bit trickier on the second one. And then it says 1,000 less than twice this amount. So 1,000 less than twice this amount would be then what? Would be then 2x minus what? Minus 1,000, right? That's our second fund right here. And what does your second fund pay out? What percentage rate? It pays out 3%. So this one's going to be 3%. And we always want to add across, so we'll just add these across. And an x and a 2x, well, that makes it 3x plus 1,000. We don't have a percentage rate on this one. So we just have our total amount. Sometimes you'll have a percentage rate that goes here. Sometimes you won't. This one does not. Now we can work with our interest. So always remember, and how I remember is 1 plus 2 is if you want to move over 3. So these add together. 1 and 2 makes 3. So those add across there. And that should be a minus. Sorry about that. Not a plus. Now we can look at our interest. Now the interest is always done the same. The interest is the amount times the percentage rate. So our first one, the first account, we go up and we look here. Unknown amount, X, 4.5%. So 4.5% would be 0.045. Unknown amount, X there. See, these just get multiplied together and placed down here. The next part is 3%, so that's 0.03. And how much is in there? 2x minus 1,000. And we do have one number that we have not talked about yet. And that number that we haven't talked about yet is the total interest. And how much total interest did I make? Looks like I made 1020, and this is your total interest. So your total interest is here, because this is the interest part, and that's that 1020. So it is a little bit more difficult to set up. We're going to now distribute that 0.03 through. And then that's 0.045x plus 0.06x when we distribute through. And then 0.03 times a minus 1,000, well, that should be a minus 30. So we're making progress here. We're going to go ahead now and combine like terms, so these can get added together. And 0.045 plus 0.06, careful with your decimals. That's 0.105x minus that 30 equals 1020. We're going to add our 30 over. And that is then 0.01, let me say it correctly, 0.105x. Moving it over gives you then 1050. We'll divide and we'll get our value of x. Now again, when we work these out, we need to make sure that we answer the question. So that's 1050 divided by 0.105, and that should come out to be 10,000. Now, what we want, let's make sure we answer the question. Well, what we want is we want both amounts. So we need to make sure that we can get both amounts. Now the first one, when we look at our first one here, its amount was x, and we found x to be 10,000. So we know that we need to invest $10,000 at 4.5%. So there's our first piece. So we need to invest $10,000 at that 4.5%. So that's our first one. Now, what about our second one? What's in the amount? So we know that's going to go down here. And what goes in that amount? 2x minus 1,000. So that's 2 times that 10,000 minus 1,000. That gives you then 19,000. So we also need to invest $19,000 at 3%. And students always kind of get confused with these, but we're going to do a lot of them. Because you use this same principle when you do the mixture problems and the distance problems and coinage problems of next week. So we'll do more of these type of problems next week as well. Now, this was an investment problem. Next, we're going to look at mixture problems, and they are very, very similar. Okay, so they're going to be done in a very, very similar manner. So we'll do 2 mixture problems, and that'll probably take care of the lecture for today, because these take a little bit of time to go through. But we're going to do 2 of these, and then we'll talk about our homework. So we're going to begin on page 91. We're going to begin with question 59. And this is a mixture problem. And what we're doing is we're mixing different chemicals together. Now we're also going to be talking about a pure. Well, what is pure? All right, well, let's take, for example, salt water. If I've got water that has salt in it, and I boil all the water out, the pure is the salt that's left over. So you've got water and you've got salt. So salt's going to be the pure. So you would boil that water out, and whatever's left, that's your salt, your pure. So a similar concept here. In a chemistry class, 12 liters of a 12% alcohol solution must be mixed with a 20% solution to obtain a 14% solution. How many liters of the 20% solution are needed? So we're going to use containers instead of dollar signs. But they're going to be done in a very, very similar manner. And box 1 and 2, they can go in any order, but box 3 is always what we want at the end. So box 3, that represents what we want at the end. And each of these has an amount, and it has a percentage rate to go along with it. Okay, so instead of using money, we're going to use boxes to represent the chemicals. We're doing it in small pieces here. In a chemistry class, 12 liters of a 12% solution. So our first box is here, 12 liters. So that's our amount, 12%. Is everyone okay with that? That's the first thing we saw, 12 liters of a 12%. So it went right here. Now we're going to mix this with something else. What are we going to mix it with? It says we're going to mix it with a 20% solution. Now, does it tell us how many liters of that 20% solution that we have? No. So that's where our X is going to go. And these add across because, remember, 1 plus 2 is 3. So these go across, and that's going to be 12 plus X when we move across. And when we mix these together, what percentage do we want to obtain? What percentage do we want to end up with? We want to end up with a 14%. So that's why that's going in box 3. Because when we mix them together, that's what we want to have. So this is where we start. So we start over here, and we start with 12 liters of a 12%. We then go to the shelf, and we grab a 20% mixture, and we combine them together so we can get the 14. Because when we're in a chemistry lab, we may not have all the different concentrations. So if the experiment calls for 14% solution, we're going to have to make that. So we got these two. We got 12% already and a 20%. So we need to make that 14 for that experiment. So this is how we would do it. Instead of interest, we work with what's called the pure. And the pure is like the interest. Pure is the amount times the percentage rate. So that's going to give us our pure. And so for our first one, our first container, we've got 12%, 12 liters. So that's 0.12 times 12. So that's these two multiplied together. Okay, so all we do when we come up with our equation is we just put these together down below. That's it. They're always done the same way. Those two go together, come down below. And what about the second one? What about it? Well, we need 20%. And what's 20% as a decimal? 0.2. And how much is in there? Unknown amount, X. Box 3 is on the other side. So what do we have? We have a 0.14. And how much is in there? 12 plus x. And now we've got our equation, and now we can finish it. So now we just multiply and combine like terms. So 12 times 0.12, that gives you your 1.44. And then we've got a point plus a 0.2x here. We're going to go ahead and distribute that 0.14 through. And that gives you then 1.68 plus 0.14x. Is everyone okay with that so far? That's all we did was distribute it through. Now we've got our equation. Now we need to solve it. So we move the x's to the left, numbers to the right. So I'm going to go ahead and move over that 0.14x. And I'm going to move over that 1.44. So those can cancel like they should. And when we put these together, watch your sign, 0.2 minus 0.14. That gives you then a 0.06x here. 1.68 minus 1.44. Well, that comes out to be a 0.24. The x's here can cancel. We can now divide by a 0.06. And now we've got our x. And so in this case, when we divide out and we get x equals now 4. So all we did there was we just took our time and we solved that equation. Now that is what we want, because we know that we need the 20% solution. And how much is in there? Our known amount, x. So what do we need? 4, and in this case, I believe it's liters. Yes, so we need 4 liters at 20%. So we would have to go to the back room. We would measure out 4 liters of that 20% solution. We would mix it with the 12 liters that we already have. And that should give us what we need for that experiment. We'll do one more. And let's look at, how about question 61? And we're now going to talk about pure. What's the concentration of pure? So, when I talk about water, okay, and I look at water, if I'm looking at this water, what would the concentration of salt in that water be? If it's right out of the tap, should there be much salt in that water at all? No. So if it's water, the concentration of salt or insecticide or dye is going to be 0. Now, what about if it's pure salt or pure dye or pure insecticide? Well, if it's pure, then my concentration should be 100%. So water is going to be 0. Pure dye is going to be, or pure salt is going to be the 100%. So remember that. So water is 0. Okay. Then we've got pure dye or pure salt. That's always at 100%. So let's look at 61. We'll read the question, and this one talks about pure dye. So question 61. How much pure dye must be added to 4 gallons of a 25% dye solution to increase it to 40%? And it says right here, hint, pure dye is going to be 100%. So let's see what we've got first. How much pure dye? That's going to go in box 1. And when it says how much, that means we don't know. So the amount of pure dye, and this is the pure here. We'll just label this up here. That's going to be our pure. And the amount of the pure dye, we don't know, so we're going to use an X. And the percentage rate of pure dye is 100%. Okay? If it was water that we were going to dilute it down with, then it would be 0. But we're looking at pure dye. So it's unknown amount, X, percentage rate 100. We're going to mix this with some dye that we already have. And we already have 4 gallons of a 25% solution. So that means we're going to come over here. We're going to use the 4 here. That's our amount. And 25%, that goes with our rate. Always remember 1 plus 2 is 3. So that's X plus 4 over here. Those add together to give you there. And then what concentration do we want? Well, we want to increase this to what? 40%. So remember, this is what we want at the end. So we want to end up with a 40%. So that's why that's going in box 3. Now we're going to compare the pures. And how do you work with the pure? Well, the pure is the amount times the percentage rate. So box number 1, the pure dye. When we talk about the pure dye, 100% is 1. Amount is X. You don't have to put the 1 there. The only reason I'm putting the 1 there is so you'll know 100% is what? 1. So that's why it's coming down. If you wanted to just write the X there, that would be okay. I just put the 1 in front so you'd realize 100% is 1. So that's where that 1 came from. What about the next one? Well, the next one has 4 liters, or gallons in this case, at 25%. So that's 4 times 0.25. And again, they can be in any order because it's all commutative. Box number 3. What's in box 3? Box 3 is 40%, so that's 0.4. How much is in there? X plus 4. So now we have successfully built our equation. We've got 1 times X. Well, 1 times X is just a single X. And then we've got 4 times 25%. 4 times 25% should be the 1 there. We'll distribute through that 0.4. And when we distribute through, that gives you 0.4x plus 1.6 there. Is everyone okay with what we've got so far? Now, when we move that 0.4 over, we need to make sure that we're very, very careful with the decimals. Because a lot of times students make mistakes with the decimals. So just so we don't make a mistake, since we've got to move things around, I'm going to use the 1.0. That way when we move over that 0.4x, we don't make a mistake. And I'll go ahead and do this one in 2 steps, just so we don't make a mistake with that decimal. So moving that 0.4x over, we have 1 minus 0.4. Be careful with the decimals. So that's going to be left with a 0.6x. Commonly made mistake is right here with this decimal. guarantee it, students make mistakes with that. And then we have a plus 1 equals 1.6. We'll move that 1 over. And again, be careful with that decimal. And that's going to then give you 0.6x equals 0.6. We'll move it over. Divide by your 0.6. And now we are left with x equaling 1. And that is what we want. We want to know how many gallons of pure dye we need. So in this case, we need 1 gallon of pure dye, or 100%. So we need 1 gallon of pure dye, or 100%. Now let's talk about our homework. So what's our homework going to be? Well, our homework is going to be 1.3, and you should be able to finish it out now. So you should be able to go through and finish out completely 1.3. Next week, when we come to class, I know we're going to have some questions over how to set some of these up. So next week when we come to class, I am not going to work the questions out completely, but I will set them up and get you to the point where you have the equation. So next week, you can answer, I'll answer any questions that you want. I'll set up the tables. I'll get you to the equation, but you're going to have to solve them on your own. So if you get stuck on some of them, bring them to class. Or you can email me throughout the week too. So if there's some of them that you specifically struggle with, just let me know. If you want to, do an email, and I can work it out for you. So our homework is then going to be 1.3. Finish that. And I will see everyone then next week.